Welcome back to our ongoing interview series with subject matter experts in the power industry. Joining us today is Bibek Karki, who is both a professional engineer and a NETA 4. After graduating in 2013, Bibek joined National Field Services as an electrical engineer. The company was acquired by Integrated Power Services in 2021. Shortly thereafter, Bibek was promoted to the role of engineering manager, which is the role he is in today. Many of the PEs I have encountered typically work in design or are perhaps the approving authority for project plans or any number of the required electrical studies that are needed for compliance. Rarely have I encountered PEs who also do field service work, but Bibek is one of those individuals, having also obtained the pinnacle of accreditation, NETA 4, for those who work for NETA accredited companies. Bibek, thanks so much for taking the time out of your schedule to chat with us. Can you tell the audience a little bit more about your background?
Thanks, Micah. Thanks a lot for having me, and thanks for such a nice intro. That was really good. Made me feel like special. Hello everybody. My name is Bibek Karki. Like Micah said, I have been in power industry for about 11 years. Shortly after I graduated with my bachelor's and master's from Southern Methodist University in Dallas, I had two choices for job opportunities. One was to write software in Pittsburgh. Another was to work in power in Louisville, Texas. So Texas kind of has been second home. So I decided to pursue the second choice, and I haven't looked back. So it's been great. Most of my job responsibilities include performing short-circuit studies, engineering studies, arc flash studies, obviously a big part of what we do, kind of bread and butter for us. A lot of relay upgrades, NFPA 70E training, technical training, helping sellers with quotations, proposals, also perform a lot of commissioning work as well, end-to-end testing, things of those nature. So I did a lot of apparatus testing early on in my career. I don't do it as much, however, I don't mind picking up a relay test set, testing some relays, or that's actually the fun side of things. So after being engineering manager a couple of years ago, like Micah mentioned, I am working on growing my team. We have a great group of guys working together. So it's been good, and I've been enjoying every bit of it.
That is awesome, and a great backstory for everyone as well. And for the audience, I did attend Power Test this year, and we had the opportunity to break bread at Power Test. Were there any talks or highlights that you found to be particularly interesting aside from your own?
Typically, I always enjoy Ryan McDaniel's presentation because obviously he does a lot of work with relays. His slideshow was really interesting. He had a couple of utility event analysis. And then another one of the good ones was Scott Cooper's IEC 6150. A lot of people kind of know that as goose messaging. I like how the grid is getting digitized, and he talked about testing a lot of the IEC 6150 it's almost like a land testing in substation, which is very fascinating. Except that, for most part, the new products, so Omicron had a really fantastic single phase voltage tester. I really like that. Global had something similar, test equipment. They are about to roll, I believe, used for IEC 6150 testing as well. And URC, all of us know as AC Pro, they had a fantastic trip unit. Again, we've been using a lot of AC Pro products in the past, and they're coming up with a trip unit which is going to be tremendous for arc flash mitigation. I kind of enjoyed that. But except that, those were really fun. And again, the most important thing was networking. I got to meet you for the first time. There were a lot of I got to meet Tom Wire for the first time. There were other guys and a lot of recurring faces. Again, power industry is so small. It's always nice to take a couple of days off. I say off from work right. and then just network and learn from each other, see what's going on with everybody, catch up, with power professionals. So it was very good conference.
It really was. And I'm always amazed at how small the power industry actually is when you get to go meet folks. And especially from a recruiter's perspective, we do a lot of hiring in the NETA space. And it's one of those things, like if you're a good player, your colleagues will sing your praise all over the place. But if you're a bad player, you're going to get found out so quickly in this space. And it was just amazing to walk around. on the show floor and see all the different folks and everybody always talking and collaborating and sharing stuff and stories. And it was just truly an awesome event. So if you're in the power industry, specifically for a NETA company, and you haven't attended Power Test, quick plug for those guys. Absolutely phenomenal event. And for most of our audience here, they don't know is you presented a paper or a presentation at Power Test. Can you kind of talk through what you presented?
Sure. So basically, like I had mentioned a little bit before, I do a lot of engineering study and relay upgrade. So my paper was kind of bringing relay upgrades along with engineering studies, along with arc flash and safety. So I wrote about the typical relay upgrade process, where I talked about improvising the relay upgrade process, where we can do arc flash mitigation if we plan it better and earlier. Also talked about NFPA 70E. Again, that's kind of Bible for us power folks anyways. So talked about kind of marrying the relay upgrade process with arc flash mitigation along with NFPA 70E. NFPA 70E has this little pyramid called hierarchy of risk control. Talked a little bit about that, and also how different methods can be applied to reduce hazard, not just say wear a PPE, right? So that, according to NFPA hierarchy of risk control, that should come all the way to the bottom of the list. So Absolutely. The paper was pretty much about all of those, talked about the different processes, field experience, had a case study, had some software simulation, not a lot of math so that I don't confuse people like Micah. I'm just kidding. So basically, I was trying to make write a paper which was obviously technical by nature, but also anyone can pick it up and hopefully get something out of it.
Absolutely. And you got to keep it simple for guys like me. Like I said, it's just one of those things for us. And I think it's awesome that you point out the arc flash piece of it. I actually had a conversation with Joel Holland last week, and we were talking about the fiber optic trip units that just increase the time for shutdown of equipment to try to mitigate some of that arc flash concerns that we have. And like we said, the PPE will get you quite a ways along, but the more that we can do to mitigate that for racking and things like that, and actually not putting people in harm's way, I think is great. And of course, the PPE serves a purpose, but the way it was explained to me is basically it's the difference between whether or not you're going home in a hospital or a coffin from that aspect of things. So anything we can do to kind of prevent the loss of life, in my opinion, is definitely well worth it. I'm glad it's become more of a regulatory requirement and getting a lot more attention these days from the arc flash perspective.
Yeah, absolutely. And again, like I said, 11 years is not a lot of experience in power industry. However, I feel like we've made so much. We've come a long way in arc flash mitigation, making customers or workers aware of arc flash. Even everybody, because all of us are around electrical equipment somehow, some shape or form, and not knowing can be very dangerous. So I know that NFPA 70E has come a long way. Also the social media, LinkedIn, even podcasts like yourselves, also a lot of conferences. There's talks about arc flash, which is what we want. We want to have that conversation. Not only people are talking about arc flash hazards now, I can see how we're talking more about mitigating arc flash hazard. It's not just five guys looking at a video of somebody getting blasted or unfortunately something bad happening. Now I feel like we're doing something about it, in a smaller scale. And also the OEMs have listened and they're coming up with innovative equipment as well. Like you mentioned, racking. There's a lot of remote racking equipment. Now we have arc quenching switchgear. So yeah, I really like the changes we have, or the strides we've made on arc flash mitigation. And again, safety is of paramount importance for everybody, right? So it's very good to see that industries kind of bought into that idea of safety as well.
And especially with it becoming the standard for the NFPA perspective, and now folks are actually required to do it from a compliance perspective. So I couldn't agree with you anymore there. Now, engineers often get a hard time from technicians, be it mechanics critiquing automotive design, and perhaps harsh critiques from testing technicians questioning why perhaps a certain relay was used or a certain piece of equipment was chosen over another, or perhaps why a substation layout even was designed the way it was. Have you encountered any of that in your experience based on the fact that you're both a PE and a field service technician?
Yes, definitely yes, I would say. It's basically, again, The disconnect I have found in the field was a lot of the technicians saw engineers where, oh hey, these guys are somewhere who's behind the computer working on their craft, and then most engineers would view technicians as like, oh hey, we provide them with guidelines, they get to do the work, right? So it's almost like there was a little disconnect. What I found was, again, earlier part of my career, I did a lot of work in field, and you would look at design and you would wonder, like, why would someone do something like that? Then I realized it was lack of knowledge, because most engineers hadn't really gone out in the field and seen the equipment condition, right? So, which is very difficult to design. You think about this, you can sketch whatever you want in any software packages, but it's very difficult to know how that gets executed, right? So again, I still think there is that gap in between, and I'm really glad that I'm on the other side of fence on that one. As in, I work with enough technicians, being a technician myself, also being an engineer myself, working with a lot of technicians. I feel like I'm the good. I bridge that gap pretty well, and which helped me a lot. Again, that has helped me a lot in my career. So yeah, especially like you were saying, on a brownfield project, on the project that you're upgrading a piece of equipment, it is very important for engineers to go out and see what's happening, and then the goal is to make process efficient. I believe everybody can do the job, everybody can achieve a goal, but to me, I really take pride in making it efficient process and easier for your guys, So yeah, it's very. I don't think it's gonna go away anytime soon.
Well, and that is definitely good. And it's one of those things, like, to me, it just seems like it's one of those obvious things, like the disconnect between an engineering and a technician. I like to use the mechanic example the most, because like if you've tried to do any traditional service work, like change oil on a car, like even on Toyotas, love their products. They're dang near bulletproof, in my opinion. That's all we drive over here. Well, you have to pull off a skid plate, and then you have to get up here, and then, or if you want to do something as basic as changing the plugs. My first car was a 68 El Camino, and it was easy. You just reach down into the engine bay and throw a socket on it and pop them out. But now they've got coil packs, and you have to remove filters and intakes, and you're thinking to yourself, like, who designed this thing? And I'm sure they're looking at it from the most efficient means of doing it from an engineering perspective. It's like, okay, we need this in closer proximity to the sump or whatever it may be. And I think that translates well with the lifelong struggle between technicians and engineers, and why there's a little bit of animosity there. And again, I don't think it's the engineer's fault. It's just the lack of actual hands-on experience, perhaps, in some of these cases. I did a traditional 4-year electrical power technology engineering degree, and it was one of those things. I remember just being in the books and in MATLAB and doing theory and physics and all the other good stuff that comes with it. But then I sit back and I think, like, when I'm at a distribution station looking at, the banks and banks of SEL relays and all that other good stuff. And it's like, I wouldn't know what to do with it from the, outside of the theory perspective of it. So I think that is a phenomenal purview that you're offered. And that kind of goes into the next question as well. Do you find that your time as a technician has made you a more well-rounded engineer? And then vice versa, do you find that your engineering time has made you a more well-rounded technician? I know we kind of touched on that, but
Sure, absolutely. Yeah, I mean, like I said, that's probably one of the best things that has happened to me in my career. I'm very fortunate to have experience. Like I said, I started early on, probably 60-40 in field, I would even say 70-30 in field, is testing 70%, 30% engineering. However, even in that engineering, there was a lot of data gathering for our engineering studies, because our engineers gather data them ourselves. So all the engineering projects, which made me realize the more you are in field, the more pieces of equipment you see, the more you interact with the gear, and you're learning a lot by observing, right? And also you're learning a lot by looking at how equipment interacts. So that helps tremendously. I'll give you an example. So programming relays, right? Typically engineers program relays and send it to technician in field. Technicians upload on the relays and test it. I know that I can tell, if you give me a relay settings file, I can probably tell you if an engineer has been in the field or not. Because for someone who has not been in field and tested the relay, they enable everything. But they would not put it as a part of a trip equation, right? Now, for someone who's been in field and actually tested the relay itself, they know that If a relay's job is to do overcurrent protection, you don't need to have 50 function enabled. You know why?
Right.
Because it takes that long time to test it for no reason, because no one's getting anything out of that testing, right? So again, I try to be mindful of our guys in field, also the knowledge I've gathered in field. Like I said, the test equipment, the circuit breakers, transformers, it helps me make my design efficient, right? It helps make my engineering study better because I have that first experience of changing settings, working on them, testing it,
Mhm.
making sure, talking about reliability. So I think it goes both in hand. And again, I'm very fortunate. I never thought my career was going to be turned out this way. But man, I am so glad I did both, and I just keep doing it both.
Absolutely. Now, do you think there's a way that engineers could kind of improve on that feedback loop? Obviously, it's best to get them out in the field. Do you think perhaps like there's a lessons learned or debrief period, or is that already kind of one of the standards in the industry? Are there any things you could to kind of improve, knowing that you have the knowledge from both the technician and engineer, pedigree behind you? Have you given that any consideration to kind of how you could make the life of engineers easier and vice versa on that one?
I mean, yeah. Honestly, the best thing would be to work together. As you're starting a career, and we try to do that with every one of our engineers. Like all of our engineers, when they come out of school and work with us, they go out and work with our field guys.
I
Again,
think that's awesome.
like you just said, the guys that coming out of school, they're going to be better with technology. They're going to understand how it should happen, right? The guys in field, they know how to make it happen.
Right.
So it's a vice versa, right? Field guy is going to test our engineers how to test transformers, how to hook up leads and everything. The engineer can help field guy understand, okay, why are we doing power factor in transformer, or what are we measuring in power factor? Not saying that the
Right.
field guys are not knowledgeable enough, but again, if you have an entry-level field guy, entry-level engineers working together, they might be limited, but they will complement their knowledge and skills. So I honestly think that I don't think there's a silver bullet, as in like reading is gonna get you so far.
Right.
At some point, you have to be there and see it and do it. It's just, I think it's a matter of getting out and then working together, and that helps sharing knowledge. It also builds a camaraderie in the team, right? And you can have a good working relationship. At that point, they don't have to, if they have any issues, we can go back and forth and resolve it, right? You don't have to be, because in the field, when I was in field working as a technician, I've seen so many times an engineer walks up, people are like, oh, here's this guy on a shiny hard hat, nice chinos, right? And here we are on our FR, it's like 110-degree day. So
Wearing
it's
your
kind of
FR long sleeve and your pants are
exactly,
all dirty as can be from
exactly,
climbing on stuff all day.
right. So I feel like that once you work together, that kind of helps bridge the gap between both, because we need both, right? We need designers, we need
Absolutely.
engineers, we need technicians, we need anybody and everybody that can that can work pretty much to meet the demand of power. So
Well, and it's just one of those things, and like I said, coming from a military background, that's where I did the majority of my testing and things like that. Like we put such a heavy emphasis on doing lessons learned in a debrief, right? So we debrief what went right, what went wrong, what could be improved, and things like that. And having not worked in the actual civilian side of it, I'm not sure how relatable that is, but that was one of those things that we just got feedback on. And you had to have your thick skin on, or they'd
yes,
hurt your feelings pretty bad. But it's one of those things like you need to know and to do it very direct and in a frank manner, you know what I mean, and do
hmm
it, but come in neutral and stay objective and kind of take those lessons learned and feedback on. So is there kind of a formal process in place, or is this more driven by technician talking to engineer, or is that something you see perhaps? I know you've been with IPS pretty much your entire career, but is there a formal process for stuff like that, for like a debrief to where the engineers and technicians must get together and talk about an install and do like a lessons learned on the backside? What could we improve? Here's what went wrong. Here's what went right. Type thing. Is that a standard process?
I would say there's nothing formal. Unfortunately, I think that's a pretty good idea. But however, there's tons of informal meetings, and definitely listen learn. Oh, absolutely, we definitely share. Typically, after it's I would say large project, obviously the project manager sends a report to the customers and everything has deficiency, everything. However, I have always asked my guys, like the testing technicians, like, hey, how did if it was, let's say, a piece of equipment that I had never interacted with, again, maybe it's more selfishly because I want to learn. I would be like, hey, how did that go? What did y'all do? Is there any shortcuts? How was the software? My biggest thing is I deal with a lot of relays. So it's always my first question is, oh, how was the software? How easy was it to get? Did you have to call like 10 people to get from Europe somewhere? Or you know what I mean? It's again, that's the field mentality of working with a lot of piece of equipment. You want to know, make sure that you have at least a software to access with or manuals, and then how testing went, what could we have done. I would say a lot of informal stuff. I don't remember a formal sit down, anything like that. It's more of like a talk and kind of like getting feedback from each other, you know.
And I'd actually be curious to know if perhaps you put such an emphasis on that because you're one of the rare ones that do wear both hats, and perhaps that is driving a lot of that wanting to know, because you may be the one doing the install of the new relay equipment next time. So any kind of intel you can gather on the front side is definitely going to serve you well, in my opinion.
Yeah.
So
yeah, absolutely.
definitely think it's smart.
And also, we do a lot of emergency responses. So I want to make sure I have as many software, as many drivers, as many cables, because there's no one I can call at 3 a.m, right?
Right.
I don't do it as many emergency responses now. But if someone calls me at 2 a.m and asks like, hey, how do I get into this relay? I can walk them through, you know. So that's the reason
Absolutely.
I want to be equipped, battle ready, I guess, let's say.
Absolutely. No, and I like, it's just one of those things that's always been kind of curious to me, because and I get it, the military's, well, technically power is life and death as well, but we just train and run scenario after scenario with various bombers and fighters and ships launching missiles and things like that, and it can be high stress, and so we had to have a formal process in place to kind of deconstruct that. And then, of course, we're just running these things for 8, 10, 12 hours a day to make sure that the warfighters on the front line are there. And I think that's one of those things that may benefit from a formal process. We mainly do like a lot of the SWOT analysis, so strengths, weaknesses, opportunities, and threat analysis. I think that was adopted from the military. And like I said, just to formalize that feedback loop, it may or may not be of any benefit, but to me it seems like it would be. And that way you kind of force that mingling of minds and to kind of have that dynamic conversation between the engineers and technicians. But that's just my little 2 cents on that from a non-technician recruiter guy.
That's a very good point. That is a very good point.
Now, we touched on learning a couple times. It's obvious to me that you value continuous learning. You're constantly generating literature that's technical in nature. I can only imagine that you're in the standards quite a bit. What are some of your go-to resources outside of the NETA and ANSI standards or the NFP? Do you have any podcasts or books or any recommendations you have for our audience?
Yeah, absolutely. So I do a lot of webinars because they're really, at first they're free, and then also they cover a lot of newer technology, which is what we're all of us trying to catch up with. So Megger has a really good monthly webinar. They pick a topic and talk about the topic itself, like let's say circuit breaker testing or relay testing, or let's say there has been a change with different type of frequency testing. So Megger has a lot of that. That's really nice. ABB does a webinar. They have fall webinar series, spring webinar series. Also Snyder used to do it. I don't think they do it now. I know that STL is very big about that. They almost do it monthly. So again, the first half of those are really nice. You learn a lot. Second half is kind of marketing oriented, where I kind of tuned it off. But again, for people who are trying to learn test equipment, that might not be a bad idea. Also, a lot of OEMs have white papers. If you select the right ones, they're short and sweet. I know that Siemens used to have tech quiz or knowledge quiz, something like that. There was one page about any industry topic. Let's say you want to learn about vacuum circuit breaker, you want to learn about contactors, just go Google their Siemens white paper, it'll pop up on their website. So that was very good. Again, there's other, basically the biggest non-formal learning is talking to your peers. I've been very lucky to work with a lot of NETA fours in my career. We have 5 of them in our company. You
That's
talk to
awesome.
them. We have fellow engineers, and again other. I have a fairly decent networking with industry folks as well. If we have any question, we bounce off ideas. There's forums such as the Electrical Engineering Portal, or I believe EEP or something like that. I just Google a lot, so it just and again, as long as you filter information, right? I mean, Google helps you as long as you know what you're getting is credible. But yeah, I mean, like I know we've talked a little bit about that, but believe me or not, a lot of interaction with fellow coworkers from different company or power folks can give you a lot more insight. There's reading there, and also there's the other side of sharing as well.
Absolutely. And I will say that was one of the awesome things. I know I keep mentioning Power Test, but just to see the collaboration, you would see, 50 different logos on t-shirts, and everybody is still sharing knowledge and stories and experience. And it's not just an isolated incident. Almost everybody I talk to says that network is so, so important. And like we mentioned earlier, the power industry is definitely small. And even though every company's got their own bottom line and PE to manage, what it really or bottom line gross profits and
Sure.
MPE money and things like that to come in to manage, but folks are so willing to share. And it's one of that that the age old adage, your network is your net worth, and I think that is definitely applicable in this particular instance. And every technician that I've interviewed just basically has just this overwhelming sense of want to share their knowledge and to ensure the folks' safety. And literally, I think that is kind of one of those things. You get kind of set up to get some of that corporate wisdom in there to where, as folks start retiring out, as long as that network continues to grow and the younger folks are encouraged to do that, I think that's going to be a large part of carrying on the legacy of that knowledge. So couldn't agree more. Obviously, all the technical documentation, also RTFM, right? Read the FN manual.
Yeah.
If you have questions, that's very important. A lot of that stuff, your time curves and stuff, are going to be in the actual dang manual.
Yes.
So that kind of stuff, but definitely having that breadth of network and that tapping into others' knowledge is just so critically important and can save you countless man hours and time and things like that. And then it's, of course, another reason that we do this is just in a digital format. I'm no expert of subject matter of any kind, maybe blowing stuff up in the Navy. But beyond that, this is just a great platform to be able to give you guys to share some of that knowledge. And that's one of the reasons we always ask, how can folks connect with you? Because they're going to see this and they're going to be like, okay, Bibek's awesome. He's got this knowledge. Let me reach out. And I've yet to have a single guest come on and say, no, I don't want to share my knowledge. They're all, hey, connect with me. Here's my number. Hit me up anytime. And I think that is a fantastic facet of the power industry. I think it's just truly phenomenal, and hope that continues on for forever.
Yeah, I know. You're absolutely right. Again, that's the essence of networking, right? You just don't in our industry. Again, I've been repeating several times. Power industries to me is very small, and then the demand is so high that there is work for everybody, right? So the competition only makes us better amongst ourselves. So again, it's not an industry where you have a lot of supply, low demand. It's the other way around. So yeah, I mean, absolutely.
Yeah,
there is. We might compete against ourselves, but we're only gonna make better, right? We want to make better test report. We want to make better. We want to communicate with the customer better. We want to. It's the poor people winning a job or getting more work are going to have all the intangibles. Everybody knows how to test a transformer. No secret there. You open a NETA manual, it lists you all the steps, right?
Yeah.
Or you open an OEM manual, it has all the steps that you could follow to test it. It's who interacted with the customer the best, who made sure all the worker was safe, who produced the best report, who responded in time and helped the customer. That's what makes the difference. So again, networking and knowing about each other's strengths, and I think it helps a lot tremendously.
Couldn't agree more. And one of the most vital things, and even from the recruiting perspective, like I said, just the ability for me to come into the power space and be able to network with you guys and to have been so well received, it's just phenomenal. And I think that speaks highly to the industry from that aspect as well. So couldn't agree more. Now I'm going to shift gears on you a little bit here. What is the most challenging repair you've ever had to conduct?
Okay, so good thing is I don't really do a lot of repairs. The end product is awesome, but the process you go through can be daunting. So we responded to an emergency in a paper mill, probably like 4 hours away from us, 4 or 5 ish hours. They had a fault on the generator PT cabinet, generator potential transformer cabinet. So it's almost, the generators are huge. They're like 28 megawatt generators. So the cabinet would probably be
Big.
like your mid-size, almost like SUV or sedan kind of cabinet.
Correct.
So it faulted, and they sent us a couple of pictures, but didn't have time. So talked to our project manager. All right, we need myself and a coworker a couple of days. I'm like, all right, cool. Friday evening,
Right.
perfect, right? So hadn't.
Just a couple of days away from home, not a big
Pretty
deal.
much, a couple of days
Typical
away
repair,
from
right?
home. The good thing is, my coworker and I, we hadn't even touched the beer yet, so we got selected on a Friday. So we left, went there, and kind of like customer opened. Obviously, we did a lot of all that good stuff, and then opened the cabinet, and it was crazy. You had a lot of molten copper, a lot of vaporized copper on all the cupboards, equipment cupboards. So we started assessing the damage. The first and foremost was clean. Start cleaning. Took us a good amount of time to clean. I would say 7 to 8 days. The biggest issue with that was the design flaw. So you have a generator here, you have a bus bar here.
Mm-hmm.
This bus bar attached to another piece of bus bar. We all know generator vibrates. This bus bar is rigid. This bus bar is rigid. See the issue there?
I do.
Vibration don't go well with rigid structures, right?
No, not at all.
So what had happened was, over the time, due to vibration, you had buses shifting, I believe. We don't know exactly. That was our guess. So it faulted. So we talked to the plant personnel and we volunteered them for design. So we came up with a design where you had a generator, instead of a rigid bus, we added flex link. So basically, anytime you had a vibration in generator, now that vibration doesn't get translated into the fixed bus in the bottom. So did that, came up with a design. Again, project took about 15, 16 days, I would say.
So much for that 2 days, right?
Yes, exactly. We had to do laundry every third day, something like that. So it was a lot of long hours, 16 to 18 hours, but it was a good project. We learned a lot. Again, we were able to help a customer. The design, as of 9:21 a.m. today morning, has worked. So that's great. So yeah, again, it was a lot of lesson learned, but a fantastic project, the one I'll never forget, just because of all what we had to do, and also the fact that we improved the design. I really love the fact that customer trusted us with our design, and this was very early on in my career too. So that was a very good learning experience.
Absolutely. And I couldn't imagine, because that's got to be like copper slag that you're just like scraping off the inside. Now, what were did you have to go in? You have to repaint it and all that other fun jazz as well to kind of get it back in service?
Yes. So basically, all the covers would have to be repainted. Pretty much the goal is, whenever fault happens, we don't want any bit of trace of carbon remain inside, right? The carbon black, because carbon is conductive, and next time you have turn the power on, so it gets conducted, and you're going to repeat the same thing. I think that's a mistake a lot of I've seen a lot of folks making when they're we call cleaning the blow-ups, right? So basically, you want to make sure you get rid of every bit of carbon black. So we took the covers out, had them, the mechanical guys over there painted NCC gray is what we used. Everything else inside got cleaned out. We replaced all the insulators because those were like ceramic insulators. Some of them had cracks. Even though we couldn't see crack on some of them, the amount of fault that had withstood, we replaced. We told them to replace everything. Got all that replaced. And all the breadboard, all the porcelain breadboard got replaced as well. We just didn't clean them because, again, want to make sure that the next design lasts forever. That's the goal, right?
Absolutely.
But
now,
like I said,
and on that,
project.
So that was a pretty catastrophic failure. Were there any indications for them? Like, what should they have seen this coming? Or, I mean, to end up with that much copper slag and everything just vaporized, would they have had any indications that piece of equipment was going to give them problems?
One big thing was it had never been maintained. And this equipment had a historical data failing after so often. This was like their fourth or fifth failure.
Jeez.
But no one thought about design because, again, for some reason, one of my big reason is a lot of people don't want to think outside the box. Another would be everybody's the plant wants to get it back on service, right? I don't blame technicians for that at all, because sometimes customer wants back on service. That your thought process on that point is like, oh, I got to get it back on service. So you start putting Band-Aid. Seems like there was a lot of Band-Aid put on in the past, and yeah, had they even done any type of routine preventive maintenance, sounding like a seller now for testing company, but that would have definitely shown them, okay, well, the design might be an issue.
Right. And it's just one of those things. The only reason I ask is because usually there's going to be indicators prior to a major catastrophe, and you won't necessarily have an absolute failure right away. So it's one of those things. And I understand the time constraints, because like when one of these plants or something goes down, it can cost to the tune of millions and millions of dollars a day, depending on what's being manufactured there. And it's in the best interest of the manufacturing plant to get back online as soon as possible, because you're affecting the P&L. So of course that introduces urgency amongst technicians just to get the plant back online. So completely makes sense from that aspect of things. And now, so we kind of touched on earlier, and you had mentioned like there's definitely stability in the industry. Can you kind of give us your take on the industry outlook for power for, say, the next 10 years? Do you think we're going to see a slowdown? Do you see enough projects coming online to where you think there's going to be work for a substantial number of years? Or what's your take on that?
It is definitely not going to slow down. Again, two reasons. To me, obviously, the population growth. Right now, all of our suburbs are kind of flexing, which means you need a lot more lighting, a lot more AC, a lot more heating equipment, everything and anything, right? That, and also the society is becoming such a technology dependent society now. Everybody has a 3 or 4 piece of equipment with you. Well, we gotta charge them, right? Also we gotta, so that, and also another thing would be the evolution of EV chargers, because the EV technology has kind of taken off. So now probably a year or two ago, you would probably see 1 or 2 car chargers on a parking garage or on some fancy hotels. Now if you drive down the street, I'm sure that number has grown exponentially. So that obviously is going to put a lot of demand or a lot of stress on the grid. So for these reasons, I don't see slowing down at all. I would only see it taking off. So I feel like it's a very good industry to be on right at the moment. We were starting on or even thinking it, just go for it.
Absolutely. No, and I couldn't agree more. And I think there's some other points to be mentioned with the EV charging stations. A lot of that, so even though you have the EV chargers, there's also the ability to use electric vehicles to back power the grid as well, and do some, or is it called back power? I can't remember what the technical term is, but it's basically feeding back into the grid and doing that. And the grid, as it was designed, was not made to do that. So that's going to require some substantial upgrades moving in the future as well. Is that a correct statement?
Yeah, absolutely. It is. And also, I'm involved with the National Society of Professional Engineer. I I got an invitation a couple of months ago to be a part of their emerging technology. And we selected the top 5 topics to talk about it. And modernizing of a grid was definitely one of them. There was AI, cybersecurity, which cybersecurity is not, I definitely understand. We do follow NERC CIP on our side of our industry as well, but grid modernization was one of the good topics. So we talk about it, we come up with ideas, try to find solutions, basically try to find methods to make it better, right? That's the whole goal. Is we're trying to make our power grid a lot better and reliable. So yeah, you're absolutely right. It just, again, the EV demand is only going to go up. You see more Teslas. Every manufacturer seems to be running towards that anyway. So yeah, we'll definitely see demand grow from here on out.
And I would totally agree with you. I think one thing that is that may be the differentiator, especially on just the EV side more than anything, I think the signal for renewables is going to consistently be there. for the wind and solar side. But with the EV side, it seems like there's a lot of push from manufacturers to start exploring more heavily into the hydrogen aspect.
Yes.
So if I could see a disruptor on the horizon in any way, shape, or form, I would say perhaps hydrogen would be one that would maybe change, not necessarily slow the need for infrastructure. We're seeing rolling brownouts and blackouts, and on occasion you'll see cyber attacks and things like that. And I think it's more, the public is more awake to that now, and it seems like talk around power stability and power security and grid security is definitely, and perhaps it's our working around the industry that it's more bought to us, but like even my kids know a little bit more about power and and things like that, whereas I don't think it was really the forefront of conversation for several decades until the renewables came onto it, and not touching on politics and climate change and all that. But it seems like one of the benefits of that it has kind of brought more awareness to power in general, and definitely not bad. So if you have the public consensus behind you and wanting that security and reliability, I think it only goes to further advance the industry from that perspective as well. So definitely great to see it here, and couldn't agree more. That's my humble opinion from an outsider's perspective, and looking at the macro. Big government's dumping to the tune of almost $1 trillion over the next 10 years, I believe it is, into infrastructure upgrades, which includes a grid hardening, more investments into green energy and renewables, which we're seeing. And that kind of leads me into my next question I'm curious about from your perspective. So we've established Industry 4.0 is not going anywhere. AI is not. We're a very data-centric society now. So to the tune of your preferred power generation method, are you a renewables, conventional, hydro, nuclear guy? What's your favorite method of power generation and why?
I know that this gets political pretty fast, but to me, nuclear and hydro would definitely be my top two choices. Obviously, you have other sources like you just mentioned, renewable, solar, wind, geothermal. Those would definitely be able to complement. But to me, nuclear and hydro both have less carbon footprint, and also I think from reliability perspective and recyclability perspective, nuclear would be tremendous. To me, I think you get the most bang for a buck with the investment in nuclear power. And now I know that there are very few scaled biopower plants as well, like methane. I've seen
biomass,
biogas. Yeah, I've actually done some projects for a couple of facilities which had biomass. I mean, those landfills, man, I was amazed how the amount of resources they use within themselves and the amount of recycle they do and reuse they do was tremendous. So even for a smaller scale, to me, every landfill ought to at least think of having something like that. But again, back to your question, I would definitely say nuclear and hydro would definitely make top two choices.
And I couldn't agree with you more. And I think that's one of those things with nuclear, a lot of people discount it. Like I said, the Homer Simpson image pops in their head, and it not being safe. But I actually saw a chart the other day, and it showed like the loss of life per power generation methodology, and nuclear had one of the safest track records of all of the various power generation methods rather. And it just goes to show you that it is safe, but for some reason Fukushima nuclear reactor meltdown didn't help us in Japan, right? Yeah. And so that was one of those things that kind of didn't help, but I think there's tons of advancements. I'm a big fan of small modular reactors as well. And mainly because I've seen how something smaller, not necessarily a modular in this instance, but nuclear carriers, submarines and things like that, we've been operating for decades on a smaller reactor and powering, our fleet for a large portion of our fleet anyway, using nuclear power. And then TerraPower, NuScale in the small modular reactor space. I think there's some really cool tech coming there. If the regulators and the innovators can kind of come together and stop fighting each other as much as they are, I think that would kind of help in that particular instance. And it's just like everything. There's always going to be a part of humanity that's going to want to regulate the innovators, right? And that's the dynamic that exists and has forever and ever. So that doesn't change. But hopefully some of the restrictions, I think, has been proven through some white papers and some other additional research that perhaps the regulatory aspects of it, which is definitely warranted. Nuclear can be bad. We think nuclear, weapons and things of that nature, obviously needs to be regulated from that, aspect of things. But hopefully there'll be a little bit more ground given. I think that's one of the major issues that NuScale is running into right now, is more regulatory compliance and getting it. And there's only a few folks that are approved for operations every year, which is just, and sometimes it takes 3 to 5 to 7 years to get through the process of just getting regulatory approval to even commit or start a project. And if you're tying that to private equity money and stuff like that, where you're looking at a 10 year horizon for payback. So I think that disincentivizes some of the investment in that field, perhaps. But again, just a layman's opinion on that, but couldn't agree with you more. Hydro is obviously amazing. Seeing some stuff happening in geothermal as well, with molten salt storage, gravity based, where they'll have a reservoir and they'll continuously pump while it's making to continue to pump water back up. So you have a continuous reserve there. Tons of really cool advances in that technology. And I will give credit to the green energy movement for some of that stuff. I think it's kind of sparked more innovation and trying to do it with a lesser carbon footprint. But that's just my humble opinion on that. But couldn't agree more. Definitely a big fan of hydro. Definitely, the SMR space, and even I won't crap on natural gas either. I think that's had a very, very viable play out in West Texas. Specifically with the Bitcoin miners that were doing the work out there. But a lot of people don't realize natural gas is just a byproduct of actually exploring for oil. It's just one of those things as a byproduct, and we're capturing it. There's less being released into the atmosphere and things like that. And that's one of those surplus resources just as a byproduct that I think is definitely a valid way to do it with a much less or a lesser carbon footprint than what you would see with, say, a coal burning plant or something like that. So, and I believe personally, there's got to be a mix, right? It can't be all or one. Like, you have to have reliability. You're not going to get the reliability out of the renewables because the sun's not always shining and the wind's not always blowing. So to have that backup. So, and that's one of those, I think we're seeing the major pendulum swings here between the climate activists and the producers over here, and that battle will continue for a little bit longer. And I think some give will be given from both sides, and I think a reasonable path forward will kind of come out of it on the backside. And also, but again, that's just my humble opinion.
Right, and also I completely agree with you on those, because the demand for power is so high right now. I feel like we can and should use every possible methods that we have.
Oh, absolutely.
I mean, for all the methods that already have been invented, and also encourage our next generation to think of something outside the box, right? There might be something we haven't even thought about it. So yeah, absolutely. I think that's the only way we're going to be able to meet the demand for the power going forward.
Absolutely. And I do, I haven't really delved deep into it, but I think the potentials associated with hydrogen fuel cells and power cells and things like that, there's still a lot going on in that space, and it's going to be interesting to see. Like I said, the good thing about human nature is we're always looking to innovate, adapt, and come up with new ways of doing things. Not always better, but hopefully it will be better.
Right. I read an article about that hydrogen. It sounded really optimistic. Interesting Engineering is something that I follow on LinkedIn, and they post like interesting videos or articles. And they had, I think it was a couple of days ago actually, they had written about it. It was, again, it's still in R&D phase right now, so there's only so much they can release, I believe. But it looked promising for sure.
Absolutely, and I think it'll be good. Well, looking back, so we've talked power. You're obviously passionate about what you do. Have you ever doubted going into the power industry? Looking back, do you wish you'd perhaps chosen a different career path, or has it always been power all the way?
It would be really. So I definitely, power kind of happened, I would say. When I came to school when I came to US in 2007 for school. I initially went to school with electrical engineering with biomed focus, because I was thinking of going to med school. Then as once you realize that you need to be like you'll be under the debt probably forever, and also by the time you'll be done with a degree, you'll be in your 30s. I was like, well, that might not be for me, more for me, you know. So I kind of switched into electrical, and even with that electrical, that was mostly for semiconductor devices and circuits. It was not power, right? So, I mean, but here we are, 10 years, 11 years later, in a power, and even in power industry. Once I initially got in, it was very different. I never had a lot of hands-on experience. Again, I started power industry working in field without any tools. The first set of tools I bought was on my first week of work. I did not know righty-tighty, lefty-loosey when I went on field on the first time. Techs had to show me after they ridiculed me for a little bit. Again, I learned.
Well, they got to give you a hard time.
Oh,
right?
absolutely. Well, the trade was that they would show me all that, and I would show them how to analyze the data they had. See, it was a fair trade. That's why I get along well. So yeah, I would say kind of like from med school ish to electrical engineering into chips design, I guess, to power. There you go.
So before, were you a PE or a field tech first? Which one transpired first in your personal timeline?
So it would field tech definitely. So basically, I started working for IPS in 2013, and then we had a very good engineering backlog. So I started doing engineering studies. However, I started my field testing right away. The first week I was hired on.
That's awesome.
I went to a project, and it was like I said, it was different. I mean, I worked 14 hours. I'll never forget that. It was August. So it was hot, humid. It was a can manufacturing factory, so it was very dirty. So yeah, at that moment, I'm like, this one is not as, like, what did I get into? However, towards the end of the day, even just the first day, it started kind of like, okay, I can see how I can do better, right? Again, like I said, I clearly remember, in field when you start early on, senior techs are like, oh, hey, you go clean or something. I was like,
right, carry the tools.
Yes, I made the deal. Okay, once I'm done with cleaning, if I work efficiently cleaning and if I finish, can I test? They're like, fair. So I like to work efficiently, right? Not rushing, but efficiently. So I was done with my task, and then I'll tell them, can I test? They're like, we'll give you to test insulation resisting of transformer. I was like, perfect, I'll take it. So I tested, and then I started asking questions. And again, a lot of them, they were doing a lot of stuff, but they didn't know why they were doing it. I think that kind of just the first day in field, talking to our guys, I think that kind of led towards, okay, this is a different engineer, because a lot of them had this persona of engineer being like, hey, he's gonna show up for a little bit, not gonna be able
khakis, with the shiny helmet.
Exactly. Not gonna be able to meet all the field demands. I'm like, I'm here to learn, and again, also earn, because we're working like as hourly employee. Yeah, you're working overtimes and everything, so it kind of worked out, So yeah.
So whenever you were hired on at IPS, was it like an EIT role? Because I know you have to do a couple of years of service, so I'm assuming they brought you in as an EIT, but they had a backlog, so you decided your time would be well spent in the field, and that was kind of what drove you towards doing both PE and field service. Is that kind of an accurate timeline there?
Yeah, so I would say, I already had my EIT done before working, so
gotcha.
Kind of started doing engineering projects. I actually did both parallelly. I would do engineering projects, and then I would help out on the field work, and then again, simultaneously. Also, a lot of engineering projects require data gathering on site.
Yes.
We would gather data from equipment that was energized and live. So I knew a lot from my field experience on how to defeat interlocks, how to wear proper PPE, what to look for. This is why efficiency matters to me. Is if I need to find a nameplate on circuit breaker, I don't need to open 10 panels. I need to open the right panel, right? Safety.
Yes.
Again, that's the knowledge that I cannot stress enough. That's the only way to learn that is working on that equipment when it's de-energized.
Absolutely.
You're testing it. So as far as timeline is concerned, so for my PE, first 4 years, you have to work under 3 PEs. So After that, you basically apply for Texas Board of Professional Engineers, and then you take a test. Once you pass the test, you have to do ethics exam, and then and there's a bunch of paperwork, fingerprinting, all that good stuff. Once it gets approved, the timeline would probably say it took me 5 years to get my PE.
Wow.
So
Gotcha.
it's a typical 4 years experience plus a fifth year would be to apply for your ethics, take a test, pass a test. Um, and again, it's an 8-hour test. That's a day. So
And I'm sure it's
basically,
tons of math and formulas and physics and applicability. And did it have a design component to it as well?
yeah, it does. It's basically like pretty much all like you said, except there's a little bit more of PE is basically from design perspective. It has nothing to do with testing.
Yeah.
That's just it helps to me. It helped me a lot. Now, as far as the NETA is concerned, I took my NETA test I believe like a year after I was in. I took my NETA 3 right before my PE because you have to have 5 years of experience for NETA 3. And the good thing is you can get one out of those 5 years from the school, right? Yay.
Right.
18 years of my school is worth 1 year. I was like, sweet, I'll take it. And then my NETA 4, for NETA 4, you have to have 10 years of experience. So
Right.
I got my NETA 4, I think last year, I believe.
Very cool. So the time, well, I guess you started doing testing pretty much out the gate.
Yeah.
But like your engineering experience, so if you're working on design and stuff, does that count towards your NETA years of experience?
Yes, absolutely.
Okay, very cool.
Yeah, as long as you're with a NETA accredited company.
NETA credit company, right?
And then you can, and again, the good thing, like I said, the reason I've been very fortunate is I actually did a lot of testing. I started doing a lot of transformer testing, circuit breakers, relays, pretty much
Awesome.
typical NETA company tests.
That's awesome, man. No, that is phenomenal. And like I said, I just think it's so beneficial for you to have been wearing both hats this entire time, because I think it really does give you a very cool and unique purview. Even the testing technicians, really, you'll see on occasion some will go and pursue their PE and they'll end up getting it as well. But I can only imagine just having the experience, the hands-on experience, the design experience, just making you, a rock star in that industry and kind of doing it, not to blow your head up by any stretch of the imagination. But but I just think it is truly awesome. And heck, maybe that's one of those things, that a PE should get 2 years of testing experience out there before they take their PE. And I think that may just result in other efficiencies there. But again, that's coming from somebody who's not working in the industry, and it's probably not feasible. So. Now, question. So AI is the talk amongst everybody for everything and all that. I've asked questions. Most of the techs I talk to say, nope, we don't want it in the test equipment. It's already dumbing down our testing technicians a little bit because the equipment is capable of doing so much where it essentially turns techs into button pushers. Do you see AI having any impact on the power industry whatsoever?
Yes, I actually do. I think the impact AI is going to have is not going to be on testing, is going to be on everything except testing, right? So once you test, you have a test report. Okay. A lot of the test report that I've written hundreds and hundreds of reports. The best way to gauge a test is trending, right? So for you to trend, you have to have a database. You don't need to have a fancy database. If you have tested that transformer 5 times and you have saved results somewhere on your folders, let's say shared folder server somewhere, you want to access that. I think AI is going to help you with that side of things. AI is going to help you sort stuff, find stuff. It's going to help you establish historical trends, and it's going to help you compiling reports, right? It's not going to help you test, and you don't want that. You're absolutely right. I feel like we've already made our test equipment so automated that if something goes wrong, the testing technician is not going to be able to figure out what they can't improvise. I'm not trying to say, saying the whole group of people, right? It's more
right.
The next generation needs to go through same stuff, use power supply to ratio a transformer, or if you have a transformer with a different ratios, be able to do some hand calculations, that's what I was meaning.
Absolutely.
So back to AI, yes, I think it'll be a tremendous asset if you know how to use it. Because to me, it'll help you become a better project manager, better tech, like a lot of better report writer, better engineer, but testing, no, I would not. It's already automated anyways, so you
Yeah,
can't. I
right.
mean, what else are you gonna do now?
Absolutely. Well, and that's kind of seems to be the general consensus. That's one of those questions I typically ask just because it's a hot topic for everybody
Yes.
right now. But Power DB data aggregation, setting up maintenance timelines, perhaps trend analysis will be another really great function of
Yep.
it, to where you can kind of start tracking. I think it was either Joel or Adam that we were talking about it, but like tracking transformer degradation. And I
Mhm.
know there's a tendency for companies that are going to go out and source a company for the lowest bid. They're not going to have any historical data to work on. So a company maybe go out and do some PM on it, right? Some preventative maintenance and all that. But there isn't the historical trends. And perhaps that'll be something that gets standardized in the future as a regulatory requirement. Maybe not. But it's one of those things that if you have that, now you can knock off, or better knock off, the minutia that's going on within the system. And I think that was a great example. If you have a trend analysis over a period of 5 to 10 years on a transformer, now you can notice those degradations as they're kind of happening along the way. And then, the ability for any third party testing company, whether it be IPS or Rezo or Sabre or somebody, come in, and now that data is available. It doesn't matter who did the prior test, but it's all there. It's aggregated. And, perhaps it's, you can connect into the master database and pull down what you need. So I could see it being beneficial from that aspect as well. But definitely seems to be the trending answer. Nobody wants it in the test equipment for the reasons you mentioned.
Right.
And I think it improves efficiency, but there's always going to be you got to give some give in that relationship, right? It's not a singular good. So by nature, by making it more efficient, humans are lazy. We all have a lizard brain by the nature of who we are. So if you make it easier, then
Exactly.
the human tendencies to go ahead and take that path of least resistance,
Right.
to use electrical
Right.
terms.
Right.
So definitely kind of see that being the case. Now, if you could go back 10 years and talk to younger Bibek, is there any advice you would give yourself with what you know now to that Bibek that's just getting into the industry? I think you've been at IPS right at 10 years. So getting ready to graduate. Oh, crap, I've got to go face the real world, Bibek, right?
Yep.
What advice would you give that guy?
I would say network a lot more, basically, and then pick up the phone a lot, call a lot of people. Don't just email and
Yes.
text them, because calling, obviously, it's a skill now, unfortunately. And then I mean, especially with industry, I feel like
Yeah.
I would say you pick the right industry. Just find a mentor a lot sooner, because that's very critical.
Mentors are
um,
huge.
and yeah, exactly. And then, just like I said, just to take more risks, learn more processes. Don't wait. Especially, I waited 10 years to present a paper or write a paper. I would definitely say expedite that process, because the more you start documenting, the more you learn, right? So I think
Right.
that's the whole reason. You just don't do writing articles and papers. I started writing probably 2-3 years ago, a lot of these. I wish I could have done better, because I had a lot of field troubleshooting that we did, never got documented, right? It's in my brain somewhere, but now I'm like, I can't remember the details. So I would
Right.
definitely say write a lot of what you did. Not like a journal, it doesn't have to be formal,
Right.
but publish more, again, take more risks, meet more people, again, and then call a lot of people. Don't just text,
Absolutely.
meet and call a lot of people.
No, absolutely. And I can agree. And I think it's kind of great that you mentioned that and have the self awareness. Engineers by nature are risk averse people. Like, they're not big on taking risk, not a full blown engineer, but have that kind of like that logical mindset that you really crunch through, and just the willingness to take risk, not in an unsafe way, but like, I'll give you, for instance, to starting this business. Like, you couldn't have talked me into starting a business until I was literally convinced by a recruiting buddy. It's like, you're really good at this stuff. You need to do your own thing. I'm like, yeah, but we're comfortable. We're retired, risk aversion, don't want to, you know what I mean? Just, and you're literally just doing this self-defeat thing by always playing it safe instead of taking the risk. And then I've always found too, and I'm sure you do a lot of mentorship as well with folks these days, but the ability to mentor and then even like you said, technical writing and going out, that forces you to go out and research so that you don't look
Yes,
stupid, and we're overcoming that
exactly.
that aspect of human nature. And byproduct, you're going to get more knowledge, wisdom that you can share and kind of start this self-reinforcement cycle. That's a very positive one in the fact of mentorship and reading and writing. And then the big takeaway for me is just being willing to take a risk,
Yes,
a calculated risk, but a risk nonetheless.
definitely,
That's
definitely.
not safety risk, but you know what I mean. Just
Yep.
for be it entrepreneurship or be it taking a new project on that you really aren't excited about or whatever it may be. So couldn't agree with you more on that one at all, Bibek. Any other insights that you would give Bibek from 10 years ago?
I would again, the mentorship to me would be again that would be my biggest thing. Is I've been very fortunate to have mentor, and again, you don't have to have mentor from your industry. I've had a mentor in school. The good thing about our school was we had a mentor-mentee program where they would pretty much pair you
Beautiful.
with your mentor. You would meet them once a month, once every couple of months, whenever, just meet for coffee, talk about again completely different subject, right? My mentor was cybersecurity personnel. I was in electrical semiconductor devices in school, and he taught me a lot about the how to become a professional. To me, that's a lot of us might be super smart, sharp, but there's a difference being a professional, right? How you handle
Absolutely.
yourself, how you conduct yourself. I think that would be that's why I cannot stress enough of mentorship. And I also had an opportunity to mentor somebody, right? I
Mhm.
do a lot of volunteering for reviewing resumes for high school students, trying to get more people to STEM. Again, I'm selfish. I want. I've always been a part of math and science, and I'd like more people to be part of that. So I think the mentor mentee is tremendous for anybody. I don't think I've ever met anybody who would ever say anything otherwise. Like, oh, I've never met a successful person. Again, it's relatively successful. It's a relative term, but I've always met someone who have helped somebody, and also who somebody has helped them. Right? It's you pass it
Absolutely.
along. So I
Yeah,
would definitely.
it's passing along,
Yep.
rituals and knowledge and a number of other things. And I will say, as a young man, I did try to fight it. So that was one of the things the Navy formalized is we had a mentor protege program that was in place. And then I used to hate it with a passion. 19-year-old goofy drinking sailor Micah out there and hating every bit of it. But looking back, it's like I couldn't agree with you more. I now understand why it was, because you just pick up so much from that relationship, and it's kind of like a father-son relationship or
Right.
mother-daughter, whatever it
Right.
may be.
Right.
You pick up so much more. It's more mirroring than it is necessarily from even having the conversations,
Hmm.
and just having that trusted agent that you can really lean into. And then again, as you get older, I think it's one of those responsibilities on us as well, as to pass down that knowledge, because I mean,
Right.
that's how you keep your history alive and your heritage alive, and corporate and wisdom knowledge alive, and all those other things. So it's definitely, to me, it's just one of those things that should be ingrained as in humans for the betterment of society. Like,
Yeah.
keep on
Absolutely.
passing
Absolutely.
down that dang knowledge.
Yeah.
Like, we all have
Yeah.
to have it, So
Exactly. Exactly.
couldn't agree with you more, man. I think that's a beautifully stated point. And like I said, it's just you and I talking here, but you definitely, I would definitely concur with you on all that for sure. Now, we're getting ready to wrap up. We're right at an hour and 10 here. Do you have any parting thoughts that you would like to share? Any last minute thoughts or anything like that?
Sure, a couple of thoughts actually. One, I know that I've been in field in power industry. There's always this ongoing debate about formal education, right? 4-year degree, traditional degree. I want to talk a little bit about that. To me,
Sure.
um, I value a formal education a lot because helped me. It helped me with a lot of intangibles. It helped me with time management. It helped me with problem
Yep.
solving, working in a team, in a non-pressure, non-formal environment. I think you learn a lot of those skills in a 4-year school. Now, I will say this though: I'm not in favor of picking one or the other. Right? You don't have to go to school and then come to work in industry. You can do the other way around, because I've seen some of
Yep.
my colleagues do it more efficiently. They went to trade school, got their hands on, come back to work, and then and get company to pay for it or something, right? Or
Yeah,
I have a lot of military,
absolutely.
like veterans. They went into military, they served, they came back, they're taking advantage of that. So I would say there's a lot of smart folks in power. I would say formal education is it is important as long as you do it right. You don't want to go to college, party through it, have a 200K debt, and then go to work, right?
And a liberal arts degree in basket weaving or something like that,
Exactly.
because that's in high demand in the outside world, right?
Well, again, that's the reason. Yeah, like so, I would
Of
definitely
course.
no, I definitely get it. It's funny how even in school we used to get a lot of that. And nothing against liberal arts. People might be, if you're passionate about it, I mean, go for it by all means.
Yeah, absolutely.
But absolutely. That's, to me, it's the formal education definitely has, I believe, has a merit, and it's that piece of paper kind of helps. It just, I feel like it gives you additional validation. It's always nice to sign and seal your own documents. To me, that's just something. And also another thing is, like you were saying, teaching and learning, right? I absolutely love teaching and learning. I would have definitely, if I hadn't been in power, I would have probably been a professor somewhere in college. But that required PhD, and I didn't want to go to school more. So here we are. But again, I would encourage everybody to seek for advices, and also for folks who have already been there, done that, share some of that wisdom, because we get better, we learn a lot by sharing. And again, it's such a small industry we work on, so it definitely helps educating the next generation, because that's the only way we're gonna get more people in power, and I guess that'll help us keep a light on. So.
Absolutely. No, and I think you have very, very valid points there with the formal education and perhaps a hybrid mix of both.
Mm-hmm.
Definitely, we're obviously, and it's a wonderful arbitrage opportunity for me as a recruiter to have a lower number of skilled trade laborers and people and folks out there that are doing the stuff to keep infrastructure operational, which is huge. And without power, everything else kind of ceases to exist. You know what I mean? So the computers don't work, the phones don't charge, and we are so reliant on that. And you have to have those folks. But again, like I just think there's less value to be given to the 4-year and my liberal arts degree joke, obviously. But like it is truly with the cost has continued to go up for formal education. And I think it's been harder for people to justify the ROI perhaps.
Right.
And perhaps had they pursued, the skilled trades and worked it up, I think it would make the studies more efficient if you just go out and work for a couple of years. And that was me. I didn't go to college directly. I joined the Navy at 18.
There you go.
Didn't go to college till I was 24.
Right.
After the Navy had trained me in the formalities of AC/DC theory and all that other good stuff, and I had troubleshooting. And then when I went and did my 4-year EPTE degree, it was easy. I mean, it really was.
Exactly.
Just because you have done the reps and sets, you've already applied the theory, you've already done all that good stuff, and it just made it easier. So I got to do a little more partying than I perhaps should have in undergrad, but still did okay in school. You know what I mean? So it was one of those things. And so that was like a nice little break. So I guess I got the best of both worlds from that aspect of it.
Exactly, man. You did it right, seems like.
Well, I like to think it's all right. We're not doing too bad. Rocking and rolling with it here. But no, couldn't agree with you more. And like I said, I try to highly encourage folks. There's honor in being a plumber. There's honor in being a welder. There's honor in being an electrician or a testing technician and all that. Of course, there's a need for doctors in formal engineering, and things. That's how we get the designs that are now implemented by the folks that are skilled trade folks. So couldn't agree with you more. And I think there's definitely a need for a good mix of those folks. And for those who are interested in skilled trades, do it. You won't regret it. There's job stability. There's no debt. You're actually getting paid to learn. And I think all those are valid things. And if you want the formal education, I mean, some people are just wired like that. They want to go do the design and they have the curiosity, but you can still obtain those goals, but now you're not going to be ladled with debt and, those burdens. So that's my humble opinion on it. And I couldn't agree more with your perspective on that. Well, any other last minute thoughts?
No, I think we've talked a lot about power industry and everything else, about my career and everything, and your insights on the reactor was very fun. That's on my reading list, so I think we covered everything, at least that I can think of. Well, if
Awesome,
if
Bibek.
there is some more, I mean, I can't give it all in one session, right? See, I gotta
Well, of
be,
course. Well, you're
I gotta
always,
be,
consider
I
this
gotta
an
keep a
open
repeat customer.
invitation to come back anytime you would like. You're more than welcome. I thoroughly enjoyed your insights and perspectives. Like I said, I think you have a very unique purview on the industry. Having achieved NETA 4 level, which is, you know, the pinnacle of testing in the NETA accreditation scale, and then having the design background and working, and you can rubber stamp drawings and arc flash studies and things like that. I think that is a very unique purview, and would definitely like to dig a little bit more. I'll just have to think of some more questions to ask you.
All right, that works.
Well, Bibek, that was a blast, man. Thanks for both your time and for sharing your story. Um, if folks would like to reach out to you, what's the best way to connect with you?
I would say I use LinkedIn a lot. Try to use it a lot, at least for networking or anything. I can definitely be reached out there. And again, anytime, like I said, it's open door policy. Really, reach out and talk about something. You know, if someone wants to grab a coffee, a beer, talk about power, whatever, I'm always up for it. So yeah, I would
And
say
having
LinkedIn is
actually got
probably.
to meet you in person and experience that, man, I couldn't agree with you more. You were definitely a highlight. I just enjoyed it, and you have such an approachable demeanor, and which led to us having a conversation. I think it's just absolutely amazing. So please continue what you're doing, and until next time, everybody, Mike out.